Okay, so in this video, we're going to be talking about how to name a transition metal ionic compound, or ionic compound with a transition metal. It's not too difficult. It follows the same naming conventions as a normal ionic compound. There's one difference though, so I'm going to rewrite that really easily, or not easily, but really simplistically. So on the left side, we have our metal as it appears on the periodic table. On the right, we have our nonmetal ending in IDE. Okay, so we're going to do some examples real quick, and I'm going to show you the next step of it through these examples, because I think if I just write it down here, it might confuse you. So we have FeCl2, FeCl3. So if you look at these, they would have the same name, but they're different. You can tell they're different because there's 3 chlorines in this and there's only 2 in this one, but there's 1 iron. So something tells me that this iron is going to have a different charge in these molecules. So what we do, because if we didn't have a naming convention for transition metals, these would both be iron chloride. And I mean, that just opens up a whole, can of worms or something that if you don't have some way of differentiating, you could make a huge mistake. So in the middle, right after, it's not in the middle, it's like literally right after the name of the metal, we have a Roman numeral. And that indicates the charge of the metal. All right, I mean, that's pretty much it for naming. How would you figure out what the charge is? Well, we have to use the periodic table. And let's make a note in parentheses. All right, so how would we figure out the charge of the iron? The charge of the chloride is going to be the same. It's -1. So the way I would do it is if I was writing FeX plus 2Cl -1, and then I have FeX plus 3Cl -1. The way I would do this is like this. So 2 times -1 equals -2. So that means the iron is bonded to something with a -2 charge, but it's balanced. This compound has a net 0 charge. So if I had x minus 2 equals 0, I could find out the charge of the iron by simply adding 2. So the charge of the iron is 2. So you would represent it as a, Roman numeral for 2. For this one, I have 3 times -1, and I'm pretty sure a lot of you already did this, but I'm going to show anyways. So x minus 3 equals 0. So if I add 3, x equals 3. Let me write x equals 2. So that means this one would be iron 3 chloride. And that is how you're able to tell the difference. So we have iron 2 chloride, iron 3 chloride. So I'm going to give you 2 examples that you can work on. And let's see. I'm going to see if you can do this on your own. So let's do just by the name. So let's do, I'm going to write the actual formula. X would be if it's got something there. Y is if, for the charge. And then oxygen would be, we'll do P and Q. So I'm going to see if you can figure out what the actual formula is for this using the periodic table. Actually, no, I can't do it this way because I have to actually, let me write the formula down. It won't work for this one. It's too specific. So I have manganese oxide. I'm going to write it MnO2. Tell me what the charge of the manganese is. How would you name it? So pause the video and see if you can figure it out. And then we're going to do one more after this. Alright, so the way you would do this is oxygen has a -2 charge. So you have a -4 charge. So the charge of manganese, since we have one of them, is X. So X minus 4 equals 0. So manganese will be manganese 4 oxide. It's really not too difficult. It just takes some practice. So I have one more for you. Chromium nitride. So I'm going to give you the formula just because I want to know what this specific formula's charge is for the metal. So take some time to figure that out, and then we're going to go over it. Okay, so the way I would solve this is we know that this has a -3 charge. This has an X charge. So we have 3 times X minus 2 times -3. Actually, we'll just put 3 and just the negative we would pull out as the minus. That's fine. Equals 0. So this right here would be your negative charge. So we have 3x equals, or minus 6 equals 0. So then we have 3x equals 6 divided by 3, x equals 2. So this would be chromium 2 nitride. And just from that, you'd be able to tell, what the charge of the metal is. And that is super important. It's really how you do the naming for transition metals. If you have any questions, please ask. The last video for this is going to be naming covalents, and we'll do that next.